Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Lesson 5 of GMAT Math Basics. We just got through talking about divisibility. But what happens when something is not divisible by something else? In that situation, you get something called a remainder. There are a lot of different ways to express remainders, and each one has distinct value on the exam. So let's talk through what those different ways of expressing remainders are and how to think about them so that the GMAT becomes easier for you. What I'm going to do going forward, in the interest of making this like your digital flashcard set or as close as possible, is I'm going to start leading each episode with the questions that I'm going to walk you through for the rest of the episode. That way, if you want to return to previous topics, you don't need to listen through the entire episode to test yourself on the knowledge that's included there. Definitely give us feedback if you are liking this or disliking it. With that said, we will update the previous episodes with these questions in the coming weeks. So if you're listening to this at least, let's say, a month from the time of publication, then the previous episodes should have a similar quiz at the very beginning. And then I will talk you through the detailed explanations of each question if you want that. I'll also re-quiz you at the end, just in case that's helpful too. Today, we're going to answer the first question of what is a remainder? So if you want to test yourself on that right now, feel free to pause. The second question that we're going to ask is, what is a mixed number? Then we will ask, what is a decimal? Then we will ask, how are decimals and mixed numbers related? Finally, we'll end by asking, what is each of the place values to the right of a decimal point called? What is each of the place values to the right of a decimal point called? Quick note on testing yourself before you learn these topics. If you're listening to this for the first time, sometimes that doesn't feel good. Like it feels like you're failing or it's pointless. Like, why would I try to quiz myself on this before I even learn the material? But there's actually some interesting research that shows it can help you retain the information in the lesson that follows better, simply by testing yourself, even if you don't really know the answers to those questions. So you don't need to do this, but I'm just putting it out there in case it's helpful. And again, we'll retest at the end if you feel like just getting some wins is going to be more important for you personally right now. Let's answer our first question. What is a remainder? Recently, I used the example of, is 100 divisible by 3? And we talked a lot about the different ways that you could answer that question. But you might have been thinking 100 isn't divisible by 3, and you'd be absolutely right about that. So when one number is not divisible by another number, and we do the division anyway, we will get what's called a remainder. So you can think of remainders as what's left over after dividing, when the division is not even. That's the word that is used to describe when you divide one number by another number and it works out to get an integer result. It's called people usually say it divides evenly. Or you could simply say 100 divides 200. But it's usually said 100 divides 200 evenly, meaning there's going to be an integer result. So let's return to the non-integer result. And I think an analogy is most helpful for understanding this concept at the most fundamental level. Let's say you're sharing a cake with 3 other people. And Let's say that there are 7 pieces of cake. The cake has been sliced into 7 even pieces. If everyone in the group agrees that no single person should have any more cake than anyone else, then the maximum quote unquote fair number of slices per person would be 2 slices each. That means everybody's getting exactly the same amount of cake. But if there are 7 slices and 3 of us have 2 slices each, you'll note that 1 slice is going to be left over. That's the remainder in this case. Let's use another example. Let's say we try to divide 9 by 4. We can get 4 to divide into 9 2 times. You can think about it as fitting 2 4s into 9, but there's going to be a little bit left over, much like my cake analogy. So again, the terminology we use here is 4 goes into 9 twice. That's how that's commonly expressed. 4 goes into 9 twice. That means you can fit 4 into 9 evenly 2 times, but then there's going to be a remainder. So we would say 4 goes into 9 twice with a remainder of 1. What that means, again, is you can fit 2 4s into 9, but it doesn't fit exactly right. 2 4s would fit perfectly into 8, but not 9. So we can fit the 2 4s in there, but then there's 1 unit left over. That's the remainder of 1. So 4 goes into 9 twice with a remainder of 1. Coming back to my intro, we can express that situation in a few different ways. One of those ways is simply 9/4 as a fraction. That's perfectly acceptable. Sometimes the GMAT will use or ask you to use that type of expression, and that's called an improper fraction. You typically do not need to know that specific term to do well on the GMAT, but it's helpful when you're studying and you're looking things up on the internet. 9/4 is called an improper fraction. The definition of an improper fraction is the numerator is larger than the denominator. It's called an improper fraction. But 9/4 is perfectly accurate. It expresses the value that's behind that signifier perfectly well. And sometimes it's most convenient to use an improper fraction to express those types of values. But sometimes it's more convenient to express that value in a different way. And this is where we get something called a whole number remainder. That's the first, simplest concept that you'll want to grasp when it comes to understanding what remainders are all about. The whole number remainder is something that the GMAT likes to test people on specifically, which can be a little bit unexpected because if you're like most of us, when you learned whole number remainders, probably when you were learning how to do long division, which we'll cover very soon, as soon as you learned about whole number remainders, you probably relatively quickly moved on from that concept to talking about mixed numbers and decimals, which is where we'll go next. But the GMAT heavily tests whole number remainders, so it's very worth understanding. Let's go a little deeper with some definitions. When we divide 9 by 4, the quotient is 2. You might remember that the quotient is another way of saying the result of division. We then write a little r next to the right of the quotient, right to the right of the quotient, and then the number 1. So the way that would be expressed by most people is 9/4 as a fraction to the left of an equal sign. And then to the right of the equal sign, you would write 2, which is the number of times you can fit 4 in evenly. That's called the quotient. And then you would write a r, usually an uppercase R, letter R, as in red, to the right of the quotient, and then to the right of that R, you would write the whole number remainder, or the number 1. What that represents is when you divide 9 by 4, it divides evenly 2 times, but there is 1 left over. That's called the whole number remainder. Most of us are used to dealing with remainders in decimal form. So like money is a good example of something that's popularly expressed in decimal form. If I log into my bank right now and I look at my bank account balance, it's probably going to express any fractions as decimals. So again, we're not used to using the whole number remainder for most of us in our day-to-day lives. That's why I'm talking to you about it right now, because you'll want to be very familiar with it for your GMAT studies. Decimals, honestly, are best understood using another way of expressing remainders that are called mixed numbers. And mixed numbers are very related to whole number remainders, but they look a little bit different. So we'll get to those in a second. For now, let's do another quick example of a whole number remainder. So let me ask you, when I divide 5 by 3, what's the quotient and what's the whole number remainder? When I divide 5 by 3, what is the quotient and what is the whole number remainder? If we use our cake example, let's imagine there are 5 slices of cake and there are 3 people sharing it, and we agree that no one person should have any more cake than anyone else. So that means the 3 of us are going to get 1 slice of cake each if there are 5, and how many slices of cake would be left over? There would be 2 left over. So the quotient when we divide 5 by 3 is 1. 3 goes into 5 evenly 1 time. And then the whole number remainder is 2. There are 2 units left over after we do the even division. So the way that we would express that if we were writing it as a whole number remainder is 5 over 3 to the left of an equal sign. And then to the right of that equal sign, we would write 1, which is the quotient, how many times it goes in evenly. Then we would write the letter R, as in red, and then we would write the number 2. That expresses the whole number remainder. Once you understand the basic concept of whole number remainders, which again, we will return to and dive deeper into when we get to long division. Once you understand the concept, you can understand the concept of a mixed number a little bit better. So we're going to move on to mixed numbers and then decimals because I think you're going to be happy we did it in that order once we get to long division. I think long division is going to make a lot more sense once we get these topics covered. So let me ask you this. If you want to test yourself, what is a mixed number? A mixed number is the quotient of the division plus the remainder expressed as a fraction instead of a whole number. It's very similar to the notation we use for whole number remainders, but instead of the remainder being a whole number, it's a fraction. Let's go further with this and let me be more specific. Let's take the example of 9 over 4 again. You might recall that 4 goes in twice, and then there's 1 left over, or the whole number remainder is 1. The way we would express that as a mixed number is 2, the quotient, but instead of writing the letter R next to the quotient, we don't write anything next to the letter R. Instead, well, that's not entirely accurate. Instead of the letter R, we write next to the quotient 1 over 4. And the top of that fraction is usually the whole number remainder, which in this case is 1, and the bottom of that fraction is usually the original divisor. We'll talk about some edge cases of that later, but for now, that's the basic convention. So the whole number remainder goes on top of the fraction, and the original divisor goes on the bottom of the fraction. Now, you may be able to reduce or cancel that fraction later, but that's the basic starting point of a mixed number. So you have quotient immediately followed by whole number remainder on top of a fraction and original divisor on the bottom of that fraction. That's how you get a whole number. So why would we even have whole numbers? Well, whole numbers can give you a little bit more information than, mixed numbers. I apologize, everybody. Mixed numbers. Why would we have mixed numbers? Mixed numbers give a little bit more information at first glance than the whole number remainder notation. So if I have 2R4, I'm sorry, everybody. If I have 2R1, which is how we would express 9 over 4 with the whole number remainder notation. If we have 2R1, then I don't have very much information about what the original divisor was. And in some situations, that's actually quite helpful. So in certain situations, you'll use the mixed number instead, which would be 2 and 1/4. That's how we would say what I just talked you through. 2 and 1/4 is the mixed number expression of 9 over 4. 2 and 1/4. And at first glance, if I say a value is 2 and 1/4, you have a little bit more data about that number. For example, it's very likely that the original divisor was 4, and that is the case here. Now, in some situations, you don't need that info, and that's why we have whole number remainder notation. So it's really just about the context you're in real life. On the GMAT, the context is the GMAT. And so they get to pick the rules of a particular question. And if they decide that the answer choices are going to be in mixed number form, then we want to be familiar with mixed number form. If they decide that the answers are going to be in whole number remainder form, then we want to understand whole number remainder form. So that's the context for you and me right now. So let's go further with this and let's help you understand mixed number notation a little bit better. Imagine expressing 9 over 4 as 8 over 4 plus 1 over 4. You'll note that if you were adding those two numbers, 8 over 4 plus 1 over 4, you probably wouldn't hesitate to add the tops and keep the bottoms the same. You might recall that that's how I recommended you think about adding fractions a few lessons ago. When you have the same denominator with a fraction, you add the tops and keep the bottom the same. So if I had 8 over 4 plus 1 over 4, you probably would not hesitate to turn that into 9 over 4. But let's keep it as 8 over 4 plus 1 over 4 for just one moment. One way to express that as a mixed number is to divide 8 by 4, which divides evenly, into 2, and then have plus 1 over 4. So 2 plus 1 over 4 would be the same value as 9 over 4. Hopefully that makes sense. If you want to turn that into mixed number notation, you just don't write the plus sign between 2, the quotient, and 1 over 4, the fraction version of the remainder. And that's how you get mixed number form. So the mixed number is just written as 2 and then 1/4 right after it with no space in between. And you say it as 2 and 1/4 rather than 2 plus 1/4. If you said it as 2 plus 1/4, like people would probably still understand what you're saying. But because you might be doing some web searching and some internet research along this path of GMAT mastery, I want you to understand that 2 and 1/4, if someone says that or types that, that means mixed number of 2 and then 1/4 right after it with no plus sign. And that's important because it's easy to get confused if you're not super dialed into these math basics from the beginning and think that that means 2 multiplied by 1 over 4, and that's not what it means. So you can think about mixed numbers as mathematically 2 plus 1 over 4, even though we're not writing the plus sign into the notation. It's really just for convenience that we don't write that. Everybody just got together and agreed, hey, what are we going to do about this mixed number thing? And someone was like, oh, let's just leave the plus sign out. And everybody was like, all right, cool, sounds good. And then now we're all living in that reality. So it's honestly not worth diving into the hardcore history there for our purposes right now. But if you're interested, by all means, feel free to look it up. And now that you understand the basics of mixed numbers, we can talk about decimals and how those are related to mixed numbers. Before we do, let's do a quick another example of 5 over 3 as a mixed number. Take a moment and ask yourself, how would you write 5 over 3 as a mixed number? Hopefully you're thinking you would write 1, which is the quotient. That's how many times 3 goes into 5 evenly. And then you would write 2, the whole number remainder, over the original divisor, which is 3, as the fraction part of the mixed number. So that would be 1 immediately followed by 2 over 3, and it would be said 1 2/3. That's how you would say that mixed number. All right, next question. What is a decimal? How would you define what a decimal is? I like to think of a decimal as another way of expressing a mixed number. It's a very specific way of expressing a mixed number. And I think you might find that way of thinking about it helpful if you weren't really able to come up with a good definition for what a decimal is. So, we actually write the quotient of a decimal exactly the same way. So that still is just the integer part of the division, the quotient, gets written down to the left of the remainder stuff. But instead of adding a fraction to the right like we would in a mixed number, we manipulate the fraction a little bit and then we put a little dot down and to the right of the quotient, and that's called a decimal point. It's like a period at the end of a sentence. And then we do something special with the fraction part of the remainder, and we write those numbers to the right of the decimal point. So that differentiates, much like a mixed number. On the left of the decimal point is the quotient, the integer part of the division, and to the right of the decimal point is the fractional part of the division, the part that's left over, the part that doesn't fit cleanly into an integer value. Now, bear with me here. This is going to get a little bit technical, but I think you'll find it very, very worth it because it's very, very helpful on the exam. So what we do with the fractional part of the mixed number is we take the denominator and we transform that denominator into something that is just a 1 with only zeros after it. Some examples of numbers that are 1 with only zeros after it. 10 is a 1 with only zeros after it. 100 is a 1 with only zeros after it. 1,000, 10,000, 100,000. Those are numbers that are 1 with only zeros after them. Some people call those powers of 10, meaning 10 to the first, 10 to the second, 10 to the third. We'll get to exponents later. So if you're like, wait, what does that mean? Don't worry about that. But if you're familiar with powers of 10, you might like to think about it that way. But I like to just think about it as, okay, whatever the fraction part of the mixed number is, I take the denominator and I transform it into a number that has 1 and only zeros after it. That's the first step. Let's start with just that step, and we'll use our example of 9 over 4 again. If we transform 9 over 4 into a mixed number, we get 2 and 1/4. So what we're going to do with the 1/4 part is transform the 4 on the bottom into something that's just a 1 and a 0 after it. Now, the most desirable first option would be transforming 4 into 10. And while that is possible, it's going to require multiplying 4 by a non-integer. We'd have to multiply 4 times 2.5 or 2 and 1/2 to get it to transform into 10, which is theoretically viable, but it's going to violate the agreed upon conventions of decimals. So remember I was talking about like everybody got together and decided that we were going to do mixed numbers with no plus sign. Everybody got together and decided that to write decimals, we were only going to use whole number ways of transforming this 4 into a 1 with only zeros after it. Okay, so it definitely gets a little bit weird, but you'll get used to it. And again, it's kind of like learning a new language. It's kind of like everybody got together and decided that in English, yes was going to mean affirmative, and then everybody was like, all right, cool, sounds good, we're going to do that. So that's basically the world we're living in now, is these people got together and we're working within that system. That's all it is. So we're not going to try to transform 4 into 10. Instead, we're going to transform 4, the bottom of the fractional part of 2 and 1/4, into 100. Because to transform 4 into 100, I can multiply it by an integer, in this case 25. If I multiply 4 by 25, I can transform it into 100, which is a 1 with only zeros after it. So what I want you to imagine right now is we took 9 over 4, we turned it into a mixed number, which is 2 and 1/4, and I want you to just, in your imagination, isolate the 1/4 part and think of it as 1 over 4 for a minute. What we're going to do is we don't want to change the value of 1/4. We just want to change the way it looks. So instead of just multiplying the bottom by 25 and doing nothing to the top, we're going to multiply the top by 25 also. And you might remember that from our conversation about common denominators, finding common denominators with fractions. We multiply by 1 in a very creative way. We're going to do the same thing here. So we multiply 1 over 4 times 25 over 25. And that would turn it into 25 over 100. And the reason we do that is a bunch of people got together a long time ago and decided that turning a mixed number into a decimal meant taking the denominator and turning it into a number with 1 and only zeros behind it, but not using any decimals like 2.5 or fractions like 2.5 to do that. So that's why we do that. It just, somebody decided it, group of people decided it, now we're doing that. So that's what we do. So instead of thinking about it as 2 and 1/4, I'm going to invite you to think about it as 2 and 25 over 100, or 25 100ths, and we'll get to the whole naming convention later. So we wind up with 2 followed by 25 over 100. Once you've transformed the denominator of the mixed number into a 1 with nothing but zeros after it, and the numerator, the top of that fraction, is an integer, not a decimal, then all you do to transform it into a decimal is you write the numerator part of that to the right of the decimal point. That's how you transform a mixed number into a decimal. So the integer part of the mixed number goes to the left of the decimal point, and the numerator of the fraction part that has been transformed goes to the right of the decimal point. So in the case of 9 over 4, we can write that as 2 and 1/4. And then if we want to express it as a decimal, we would change the 4 into 100 by multiplying by 25. We would multiply the top of the fraction by 25 as well. We would get 2 and 25 over 100. And then we would simply write that as 2 period 25 to the right of the decimal point. That's how you transform 9 over 4 into 2.25 by way of mixed numbers. Now, it's important to say this isn't the only way to think about decimals. I just have personally found, teaching people this a lot over the years, that when it comes to rebooting your math skills, for the GMAT specifically, that this is the most productive way to think about it from the beginning. Now, I will give you more advanced and other ways to think about it, but I want to keep things simple and I want to keep things on an upward sloping exponential learning trajectory. And I promise if you're not already experiencing that, then you will by the time we're done with this program. Not this specific lesson of it, but the entire series of lessons that we'll get to later. So, even though that's not the only way to think about decimals, I think it's the most helpful way to think about decimals for now, because it's going to allow you to move back and forth between whole number remainders, decimals, and improper fractions, and mixed numbers. And being able to move between those things is really, really valuable on the GMAT. You might remember that I said earlier in the program, not this lesson, but previous lessons, the GMAT tests very simple things, but in complicated ways. We're going to see some examples of that a little bit later in this lesson. Moving between these concepts is a great example of testing a simple concept, but in a potentially complicated way. There's all kinds of tricks and hacks and weird things they can do to kind of mess with us just based on these simple concepts of transforming the same value into different depictions of that value. So 9 over 4 versus 2.25. It's really valuable to understand the mechanism of that transformation, even though it might seem like we're getting super in the weeds. I promise you're going to be like on the GMAT seeing a problem like, oh my gosh, thank goodness I knew that. So let's convert a few more mixed numbers into decimals, because this, I think, is the most weird and specific and technical part of this whole lesson. So let's go for 5 over 4. Switch it up a little bit. To convert that to a mixed number, figure out how many times 4 divides into 5 evenly. In this case, it goes in 1 time, and there's 1 left over. If we had a cake sliced into 5 slices and 4 people sharing it evenly, everybody could get 1 slice and there would be 1 slice left over. So you can think about it as 4 and 1/4. Or, if you liked the earlier way I did it, of splitting 5 over 4 into 4 over 4 plus 1 over 4, you can divide the 4 over 4 to create 1, and then the 1 over 4 comes to the right of that, and you just omit the plus sign. You just leave out the plus sign. All right, so we would get 1 and 1/4. Let's turn that into a decimal. 1 goes to the left of the decimal point because that's the quotient, the integer part of the division. The fraction part is 1/4. So let's make the bottom into a number with a 1 and only zeros after that 1. We already did that earlier by multiplying 4 by 25. So hopefully that's familiar. And we want to make sure that we're not changing the value of the fraction, just changing the way that it looks. So instead of just multiplying the bottom by 25, we multiply the top by 25 and the bottom by 25. So that's like multiplying by 25 over 25, which changes the way it looks, but it doesn't change the value because we're just multiplying by 1. That would yield 1 and 25 1/100ths, or 1 plus 25 over 100. So again, we keep the quotient part to the left of the decimal point. That's 1, and then a period. And then to the right of that, we write the numerator part of the fraction that has only 1 and zeros following the 1 in the denominator. And that yields 1.25. If you want, you can test that out by putting it into a calculator or asking your favorite voice activated AI if you're in the car or at the gym, what's 5 divided by 4? And it'll probably say 1.25. Or maybe it'll say 1 and 25/100ths. In fact, if you've got a smart computer with you, you might even ask it to express it to you as a mixed number and see what happens. Now, I admit this is a very technical and somewhat laborious way of transferring between mixed numbers and decimals. And if we didn't have to do it this way to get incredible GMAT scores, then we honestly wouldn't. We would do it one of the simpler ways. And we'll talk about those simpler, maybe just different ways down the line so that you have access to a variety of moves when you are under pressure when it counts. And probably for a lot of these calculations, they'll just become totally second nature and natural. Like you probably won't even have to think much at a certain point to transfer 5/4 into 1.25. Like those will just become naturally the same thing in your mind if they aren't already. But for some of you who maybe just didn't have the best math instruction from an early age, or the class moved on without you during this part of your development, or it's just been a really long time since you thought about whole number remainders, I want to start with the basics so that we're being as equitable as possible with our offerings here. And then also, like I said, the GMAT can test you on the very foundational concepts behind those math moves. And I've found some people think like, oh yeah, 5/4 is 1.25. That's easy, Isaac. Like, why are we even talking about this, man? What the heck? You're wasting my time. And then they get to the GMAT and they're like, oh, I see why he was talking to me about that. And it can be a very important moment. Let's just put it that way. So just trying to set you up for success is what I'm trying to say here. So with all that being said, you'll probably end up memorizing some really common fraction and decimal equivalences, like 1/2 is 0.5, 1/4 is 0.25, and things like 1/3 is 0.333333333 forever. We'll get to the whole concept of repeating decimals later, but for now, I want to stay focused and keep it simple on just like what is the relationship between decimals and mixed numbers and why do they exist and how do I move between them. And we will get to repeating decimals when we talk about long division down the line, because that's probably the easiest way to understand those repeating decimals. But those do exist, and we will cover those in due course. To tie this off, though, now that you understand how to transform mixed numbers into decimals, ask yourself, just quiz yourself for a second, how would you transform a decimal into a mixed number? Thinking about that and walking through it is hopefully going to help you understand this whole process a little better. So let's walk through an example. What if you need to manipulate 3.7 on the exam? There's a lot of different ways you can manipulate decimals. Again, we'll get to those very soon. But for now, let's transfer it into a mixed number. A decimal is a mixed number where the numerator of the fractional part of the mixed number is written to the right of the decimal point. And it's just assumed that the denominator of that is a 1 with only zeros after it. So if we wanted to transform 3.7 into a mixed number, we could write it as 3 plus 7/10. How does that work? How do we know that 0.7 equates to 7/10? Let's talk about that. Let's use another example to dig into this. Let's think about 3.76 as a mixed number. We take what's to the right of the decimal point, which is 76, and we say, okay, what if we made that 76/10? If we actually did the division there, you'd realize, and we'll get to the mechanism of this later, that yields 7.6. Think about it this way, just based on our current knowledge base. 76 divided by 10 actually yields an integer. 10 goes into 76 more than one time. So you need a number that is not going to divide evenly into 76 even one time, which is another way of saying you need a number bigger than 76. All right, so when you're transforming that decimal part, into the mixed number form, you want to look at the decimal and you want to say, okay, what's the number that's slightly larger than this number? That's just a 1 with only zeros after it. So let's go back to 3.7. The 0.7 part, how did I know that should be 7 over 10? Well, what's the number that's bigger than 7, but is a 1 with only zeros after it? 10. 10 is the next largest number, bigger than 7. That's a 1 with only zeros after it. And that's a quick sort of like memorizable way that you can make that switch. All right. We'll dive into the more heavy duty specifics behind it later, but I don't want to overload you for today's lesson. Now, with 76, we'll ask the same question. What's the smallest number that's bigger than 76? That's a 1 with only zeros after it. That's 100. 100 is the next largest number above 76. So when we do 3.76, we write that as 76 over 100. Now, you might be thinking like, wow, this is really technical. These are a lot of rules. That's true. That's how we work with decimals. That's how you understand decimals. Now, you also might be thinking like, man, like, do I really need to know this to be a better business person? Like, how is this even relevant? I will talk about that at the end of the episode. A lot of you are just like, hey, whatever, just give me the technical parts. So that's what I'm going to go through first and concentrate on here. But if you're kind of feeling like, man, this is hard, this is confusing, I don't like this, I don't like the way this feels, don't worry about that. You're building a new skill set. It's natural to experience a little bit of resistance, and you can think about it as resistance training. Without resistance, you're not going to get stronger. So if you're feeling a little bit of resistance, that's actually probably a good thing. And we'll talk about the skills behind these skills that you're building that actually will make you a better business leader. If you want more of that, you can fast forward to the end of the episode now or just hang tight. I'll get to it momentarily, okay? So if you're like, wait, how does this make me better at business? I promise there's some rhyme to the reason here and some reason to the rhyme at that. All right, so 3.7 becomes 3 and 7/10. 3.76 becomes 3 and 76 100ths. Now, you can reduce the 76 100ths part if you want to. We've already talked about how to do that, so I'm not going to rehash that here. The last topic for us to discuss in order to round out your basic understanding of decimals, remainders, and mixed numbers is what we call different place values for decimal numbers. And this is very related to what we were just talking about. So remember I said 3.7, you take the 0.7 and say, okay, 0.7 or just 7, what's the next largest number than that? That's just a 1 with only zeros after it. That's 10, so it's become 7 over 10. And you just memorize that that's how you do it. That'll help you remember that the first place value to the right of the decimal is the tenths place, because when you write 0.7 as a fraction, it's 7/10. Let's talk about that for a second. So quiz yourself real quick. Do you know the place value names for all the place values that go to the right of a decimal? All right. So I just did 3.7. That's 3 and 7/10, or 0.7, that first place after the decimal. First place to the right, digit place to the right of the decimal is the tenths place. Let's return to the example of 3.76 and let's talk through this. If you express it as a mixed number, you get 3 and 76 over 100 if you don't reduce the fractional part of it. So how would you speak that fraction to somebody if you had to verbally express it like I'm doing for you right now? You might say 3 and 76 over 100, or 3 plus 76 over 100. That's correct. But you also might say 3 and 76 100ths. And to make sense of that, you might like to return to the cake analogy that I've been using. So imagine we take a cake and split it into 100 pieces. And we share it amongst 76 people, and we say the sharing has to be totally equitable. Nobody can have any more than anybody else. So each person of the 76 people gets one slice, and there are 24 of those 100ths left over. And we gave out 76 of those 100ths. And so the way we talk about each slice of the cake is the number that it's been split into with a THS after it. And again, somebody just got together and decided that's how we're going to do it, everybody. And everybody was like, cool, sounds great. And then that's what we got. So Let's pick a couple other examples and let's try to make this a little bit more real. If you like the cake analogy, imagine a simpler example. We cut it into 7 slices, and you might just call one of it a slice, or you might call it 1/7 of the entire cake. So, how would you describe 2 slices of that? You'd probably say 2/7 of the cake. 3 slices would be 3/7. So, again, we just take the number it's been split into and put a THS after it in general. Now, it's valuable to describe this way of naming pieces of something because it'll help you understand decimal and decimal places better, but also the exam, the GMAT exam, uses that naming convention. So that's why I'm defining it for you here in such vivid terms. It'll help your score. So recall our discussion about place values from a few lessons ago. We talked about numbers like 107, which is 100, 0 tens, and 7 ones. That corresponds to what we called the place value or the digit of each number. The hundreds digit is 1 in 107, the tens digit is 0 in 107, and the units digit is 7. That's how we construct the number 107. But you might notice all of that is to the left of the decimal point. So, how do we name the places and the sequence to the right of the decimal point? Again, the first place to the right of the decimal is called the tenths place. And that's because if we transform it into a fraction, we've just memorized the rule that the denominator becomes the lowest number that's a 1 with only zeros after it. You just memorize that that's the convention. And that'll help you remember that 3 over 10 is the same thing as 0.3, which is said 3/10. That first place value, first digit to the right of the decimal point, is the tenths place. Let's move to the hundredths place, and let's return to 3.76. So that would be 76 over 100, or 76 hundredths. And that's written as 0.76. And that second place value, that second digit to the right of the decimal place, when we have 0.76 written, the 7 is in the tenths place and the 6 is in the hundredths place. So you could think about constructing that number as 7/10 plus 6/100. 7 over 10 plus 6 over 100, if you found a common denominator, would yield 76 over 100. Okay, so all of this is building on what we've already talked about with fractions and common denominators, etc. Now, if you're not feeling like you're really grasping the theoretical basis for these place values, you can just memorize, okay, first to the right of the decimal is the tenths, second to the right of the decimal is the hundredths, third to the right of the decimal would be the thousandths, and you can just memorize that convention. That's fine. You don't need to understand it any deeper than that, but I wanted to at least try to describe it a little deeper so that our future conversations will be a little bit hopefully easier to understand. Let's quickly use the money analogy, which is probably the safest and easiest to understand analogy for decimal places. And then we'll wrap up with a quick re-quiz and a little bit of like the mindset behind learning this stuff. So think about something that costs $1.25 or $1.25. You might think about that as $1.25. And that's actually saying it as a mixed number. But if you think about cent, the word cent, that has its roots in older languages that preceded English, and cent means 100. So that's where we get the word per cent. That means for every 100. And if you think about writing percents, you probably think about it if you were going to transfer it into a fraction as something over 100. That's percent. And so the word cent, 25 cents, means 25 hundredths. And that little analogy can help cement some of what we were just talking about in your mind, hopefully. So again, just to recap, immediately to the right of the decimal place, we have the tenths, and immediately to the right of that, we have the hundredths. and then we go the thousandths and the 10,000ths, et cetera, et cetera, et cetera. So again, because the exam is going to test these simple concepts in complicated ways, you'll want to understand these super basics super, super well. So that's what I'm trying to do, just setting you up for future success with the exam. And the business analogy maybe here would be like not just understanding how to make the PowerPoint deck, but understanding why you're making the deck and for whom you're making the deck. Because when you understand those two things, the basics of why you're making the deck, the purpose of it, and for whom you're communicating the information, you could deliver the same result as the deck with a spiral bound printed notebook. Or you could deliver the pitch orally if you needed to do that. And that's the kind of thing that the GMAT likes to do. It likes to test you like, okay, you made the deck, but could you give the presentation and the pitch like without a deck or without any printed materials? You know, it's under that's what we're trying to help you move between like, okay, yeah, I could construct the deck, but I also understand how and why the deck is constructed. That's a little bit of the business analogy here. So if you're going to be tested on that stuff, you'll want to practice it. So again, we might just seem like we're talking about numbers and maybe there's no relevance to business, but we'll get into that in a sec. For now, let's summarize the quiz that I gave you at the top of the lesson. Number one, what is a remainder? How would you define a remainder now that we've had this discussion? I like to define the remainder as the leftover after dividing when one number is not divisible by another. Requiz, what is a mixed number? How would you define it? I like to define a mixed number as a way of expressing the result of division with the quotient on the left and the remainder in fraction form on the right. Next up, what is a decimal? How would you describe or define a decimal? I like to define it as a way of expressing the result of division with the quotient on the left of the decimal point and the remainder part on the right of the decimal point. Now, we got into a more technical definition about the numerator over a denominator with one and only zeros after it. You can memorize it that way too. Next up, how are decimals and mixed numbers related? How would you describe that to somebody? I'm going to invite you to pause and think about this. See if you can generate an answer for yourself. The way I like to define it is a decimal is a way of expressing a mixed number, with the fraction form having a power of 10 in the denominator, or a 1 with only zeros after it in the denominator, and then taking only the numerator piece and placing it to the right of the decimal point. That's how I like to define a decimal. Final question. What is each of the place values to the right of the decimal place called? How do you name each digit to the right of a decimal? To the left, you have the tens, the hundreds, and the thousands. To the right, you have the tenths, hundredths, and thousands with a THS at the end rather than a DS at the end. So that's it. If you feel complete with this lesson, I invite you to move on. I'm going to talk a little bit about the mindset behind this stuff. If you're like, wait, why? Why do I need to learn all this? How is this helping me becoming a better business person? This feels dumb. It feels irrelevant. What's the deal with this? Here's how I'd invite you to look at it. See it as a combination of several extremely valuable executive skills that you're developing by learning all this stuff. Number one, the ability to process data faster and more accurately. If you took the time to do drills on what I just talked to you through, you would be building up your mind's ability to process data faster and more accurately. A lot of the calculations that we did and the more complicated versions of them are not necessarily easy calculations to do in your head or even to do by hand for a lot of people. A lot of people make a lot of mistakes. And for most of you, you're going to have to improve your existing ability to calculate in order to get it fast enough to get good GMAT results. So let me ask you this. As an executive in any company, who would you rather be? The person who can process numerical data quickly and easily because you've built that skill? Or would you rather be the person who has to ask everyone to repeat themselves 3 times in order to get the point and to understand the data? Who would you rather be as a leader? Let me ask you this. Who would you rather work for if you were going to work for someone? Would you rather work for the person who can process the data quickly, whether they do that naturally or whether they built up the skill over time? I know which camp I'm in. And so if you're not already great at it, this will help you be better at it. And believe it or not, that will pay dividends down the line. Even if it seems like, man, this is so lame. I'm just moving numbers around between different forms. Like, what's the deal with that? Well, arguably, a lot of business is just moving numbers around in different forms. Number 2 reason that this can benefit you. The ability to develop and execute on a proven process. The ability to develop and execute on a proven process. Do you think that that is a valuable executive skill? I do. Let me ask you this. Have you ever had a boss that tells you to follow the rules but does not follow them him or herself? Do you want to work for that person? If you became that person, do you think top people, the most talented people in your industry, would want to work for you? The ability to execute and develop a proven process is extremely valuable, even if that process is boring or might seem irrelevant to the moment. Processes matter. Processes matter in business. The last thing you're developing here is attention to detail. That's a valuable executive skill. Have you ever worked for the person who gives really general instructions, but then criticizes you for not doing things correctly? Do you want to be that kind of leader? Let's be real. This is not the kind of thing that we need more of in business leadership. We need people who can walk the walk. People who aren't just telling you to follow the process and be detailed with the process, but people who are developing, following, iterating, and being so detailed with their own process that even just looking at them, you're like, whoa, this person has it together. This person is doing something right. I automatically, subconsciously just believe and respect this person a little bit more than if they were kind of the loosey-goosey type of person. Now, I'm not saying appearances are everything. They're obviously not. I'm just saying when you work with the person, you're going to have a pretty quick read on whether they're detail-oriented and capable of sticking to a proven systematic process pretty quickly, and they're going to see the same thing in you. So the best strategy in that situation is be the kind of person who can develop and execute on systematic processes consistently over time with high attention to detail. And if you can do those things, which is a side benefit of doing all the work that we're doing here today, then you're going to be a better executive. And that's the whole point of our work here. So again, if you're thinking on the surface, this is dumb, why would I ever need to do this in business? You probably don't need the specific skills in business, but the skills behind it, you definitely are going to want those. And it'll help you, believe it or not, be much better at what you do. So real quick note about AI, if you're thinking, I can just ask AI to do this math for me in the future. Why am I being asked to do it on this exam? That's true. That's true. You probably will be able to do that, and you can probably do it right now. But let me ask you this, relevant to our previous discussion. Can you ask AI to lead your team? Can AI make your team respect you more while you're being lazy and unfocused with your own disciplines and processes? Probably not right now, unless you know a lot more tech than I do. And that's probably not going to happen anytime soon. It's very unlikely that you're just going to be able to delegate respect or respectability to AI. So again, are these the only skills you need? Obviously not. But I'm just giving you some perspective in case you're like feeling a little weird about this whole process of building up these math basics from nothing. And maybe you're even feeling like it's a significant challenge. Okay. But the other skills you're going to get in B school or you're getting in your current job or you've already gotten. And so we're not going to talk about those here. We're going to focus on the basics because that's probably what you need help with at this point in your journey. All right. So basic skills of data rate, basic skills of execution, basic skills of personal growth are the foundation of being a great performer. And you are also building those as you are building your math basics skills. So if you're feeling a little bit of resistance here, Try not to focus on the relevance of the specifics of, do I really need to know what a mixed number is and how to transfer that into a decimal to be a great executive? Probably not. But building the skills behind those specifics that you're building by building up those skills of moving decimal points around and understanding how mixed numbers and decimals are related are going to help you develop the executive leadership skills that will be really critical. Okay. And let's be honest, even if you're great at all of those things, following a consistent process, even if people always already respect you, could you be better at those things? And would that probably make you an even better leader? Probably. Is that the constraint on your leadership right now? Maybe, maybe not. But it's not going to hurt. That's it. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our video presentation on how to achieve your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe. And as always, please stay positive and stay consistent with your studies. You can do it. I'll talk to you all soon.